very good afternoon to all and one present here. I am Dr. Vandita Kakkar, Assistant Professor at University Institute of Pharmaceutical Sciences, Punjab University, Chandigarh. And I'm here to share with you a very important piece of research which was done here by our research group, and that is evaluation of tetrahydrocurcumin-loaded lipidic nanoparticles incorporated within tacrolimus ointment in vitro and in vivo assessment. So before I move on with the slides, I wish to introduce you all with the two basic molecules, that is curcumin, which probably all of us we have heard of it, which is obtained from turmeric. And turmeric we are using at home, haldi. So tetrahydrocurcumin is a metabolite of curcumin, which was very much unexplored, though it had very good antioxidant potential. But, its therapeutic efficacy had never been explored. I'm talking about it long back, 10 to 12 years. Now it's been more than a decade I've been working with this molecule. So this curcumin is yellow in color, and it has a problem that the bioavailability of curcumin is very low as below 1%. And when we talk about the solubility of curcumin, even it is very low. It's only 11 nanogram per ml. While when we transform it to tetrahydrocurcumin, which I said is a metabolite of curcumin, it is very stable at physiological pH vis-a-vis curcumin, which is very unstable at physiological pH. Apart from that, it is white in color. Tetrahydrocurcumin is also referred to as white curcumin because it is colorless hydrogenated product which is derived from yellow curcuminoids. This molecule has much more superior antioxidant, anti-inflammatory, and antimicrobial properties as compared to the parent molecule, which is curcumin. When I started to work with this molecule, we were very apprehensive because curcumin was being developed by us as a topical molecule also, and even as a oral delivery also. And it was really working very well, whether you talk about the neurodegenerative properties of curcumin, whether we talk about the wound healing properties of curcumin, it was working quite well. But the only problem which we were facing is that, it wasn't stable at physiological pH of 7.4 when we talk about the oral delivery. While if you're talking about the topical delivery, the staining was a big problem. So this molecule was selected with a hypothesis that yes, it's going to have very similar profile as curcumin, but it's going to be colorless. It's not going to stain your clothes. And apart from that, it's going to be very stable. But the challenge was, again, the poor solubility of tetrahydrocurcumin. Looking into this molecule was nano-coated, and out of all the nano delivery system, the lipidic nanoparticles, they were being selected as a carrier for incorporating the white curcumin because of the advantages which these lipidic nanoparticles they possess. So no organic solvent was being used, though we do have methods to prepare lipidic nanoparticle via the organic solvent method as well. High drug payload. So the beauty of the lipidic nanoparticle formation is that it can incorporate both the hydrophobic and the hydrophilic drug because of the structure. So we can very clearly see that we have two layers. One is the solid matrix, that is the solid lipid which we are going to use, and the co-surfactant co-layer, which is the emulsifier layer. So, the drug is contained in both the phases, the solid matrix and the layer that is the phospholipid layer. And while we talk about the release, we see a burst release because of the release of the drug from the phospholipid layer. And then by the phenomenon of diffusion and by erosion, the drug gets released from the solid matrix. Apart from this, the lipid which were used, they were biodegradable. Because the particle size was kept below 200 nanometer, they could bypass liver and spleen filtration. They excellently give a controlled release, very feasible large scale production, and even sterilization is possible while we talk of lipidic nanoparticle. And finally, the stability, which is the most important thing while we talk about any formulation. Now, because we were talking about skin inflammatory condition, so here these lipidic nanoparticle they were being prepared, first concentrated, and then incorporated into a tacrolimus ointment. So, in the forthcoming slide, I'm going to tell you why did we incorporate it into the tacrolimus ointment. Now, the purpose of having this nanotechnological implementation was because of the small particle size, it's going to bypass the stratum corneum, it's going to remain there for a longer time period, release the drug, relieve the inflammation. Non-staining, it's a non-irritating gel. It increases the permeation across the skin, increase retention, and finally, because we are reducing the particle size, we are going to reduce the dose of the drug, and finally, it's going to enhance the bioavailability of the drug. Now, the method which we used was a very simple and a spontaneous method which could be very easily scaled up, wherein we had two phases, the lipidic phase, the aqueous phase. Both of them, they were maintained at a temperature 10 degree above the lipid melt temperature. The lipid in this case was compritol 888. And by having that optimized ratio, we could have a clear emulsion. And this clear microemulsion was then finally transferred into the cold water under a very high speed stirrer of at around 13,000 rpm for a period of 20 minutes. And this finally resulted in the SLNs after we homogenize using the ICA homogenizer. So, for this technology, specifically for the white curcumin lipidic nanoparticles, we have been granted the patent, the Indian patent, and the title of the patent is Topical Nanoformulation of Tetrahydrocurcumin. Coming to the characterization of these lipidic nanoparticle, the particle size, as I told you, was below 200 nanometer, and that is the requirement even while we are talking about the bypassing of the stratum corneum when we are talking about skin inflammation. So this particle size plays quite a good role. The PDI, that is the polydispersity index, which indicates the monodispersity of the particles which have been formed, must be less than zero point 0.3, and we could attain that value quite well. While zeta potential indicates the stability, which was again in range. The total drug content was 95.5%, quite a feasible and acceptable range, and entrapment efficiency was 83%. So by entrapment efficiency, we mean the amount of drug which could be loaded in the matrix and the layer, the phospholipon layer which was present. Herein, we can very clearly see the TEM examination, which confirmed that the particles were uniform and the particle size diameter was between 100 to 200 nanometer. The shape also represented the lipid polymorphic form from circular to the polyhedral particles, which indicated the amorphous nature of these particles. We had a beautiful tracking system. So this study was carried out at University of Lancashire, UK, in Preston. And one of my students, she got the Commonwealth Fellowship. I don't know if I can play the video as well. Can I do that? I think it's not getting activated. Okay. So we analyzed the particles using the nanoparticle tracking analysis system, and we could check the concentration and we could see the movement of these particles very well. Let me check if I can play the video as well for you. Yeah. So here is the nanoparticle tracking system, wherein you can see very clearly the monodispersity of the particles which have been formed. And in this fluorescence mode, you can see the the density of the lipid particles which have been formed. So this very clearly indicates that how beautifully the particles they have been formed here. And we obtained the mean particle size again. The NTA also depicted that the particle size was 153 nanometers, and this was in line with what we could observe with the zeta sizer and what we could observe with the TEM studies. Coming to the preparation of the ointment, as I told you, that the purpose was to formulate an ointment for the treatment of psoriasis, for the treatment of dermatitis. So, this molecule, Tacrolimus, if we talk about, it is a second generation calcineurin inhibitor, and this molecule is available in the ointment form in the market. It's marketed by Glenmark, it's marketed by Panacea. It's available in two concentrations in the market, that is 0.1% and 0.03%. The problem with tacrolimus is a black box warning given on the box that if you're going to use it chronically at a concentration of 0.3%, there might be chances of getting cancer. So our purpose was that while we are going to synergize the concentrated lipidic nanoparticle with the tacrolimus, we are going to reduce down the dose of tacrolimus also. So we used here the concentration of tacrolimus as 0.03% along with 2% concentration of lipidic nanoparticles of white curcumin. And for the preparation, we took lipidic nanoparticles, lyophilized them, and finally added it into the ointment in accordance to 2% weight by weight, leading to the formation of a homogeneous ointment. Finally, the ointment was being characterized for the texture analysis, which was found to be quite reliable. The spreadability, the texture, it is totally free of grittiness. Short term toxicity studies indicated that there was no change in the cell morphology, the structure of the skin of the animals on which it was being tested. It very clearly indicates that there were no sign of skin reaction or inflammation. The integumentary system was intact, stating that all these strata, including all the cellular components, they were intact, and there was no change which was observed here. The supportive glands were very well defined without showing any toxic reaction on the skin. Coming to the acute and chronic dermal toxicity studies. So, when we talk about any novel molecule, when we talk about nanotechnology, so anything which we plan to commercialize needs to be tested preclinically thoroughly. So, in accordance to the OECD guidelines, we perform the acute and chronic dermal toxicity study, wherein we could see that in this 28 days toxicity study, there was no change per se in any of the organs where we tested the THC SLNs in the ointment form or in the nanoparticulate form per se. Though, if you observe it, the observe in case of only the lipidic nanoparticle, we could see some infiltration in the lungs, while there were no changes when we talk about the tacrolimus ointment, which has been patented here. So there were no marks of skin reaction or inflammation. There was no mortality, and no changes were observed in any of the treatment group. Then we performed the cytotoxicity studies by using the MTT assay, and it was seen that there was no cytotoxic potential of these lipidic nanoparticles loaded with tetrahydrocurcumin and HECAD cells, and no cytotoxicity was observed at concentrations below 20 micromolar during the 48-hour time interval. Cell viability was also tested on the HDF cells, that is the human dermal fibroblast cell, wherein we could see that the HDF cells were 98%, 86%, and 72% viable. Post treatment with the THC LNs, that is the lipidic nanoparticles, even after 24 hours. So we can see that the highest viability is with the lipidic nanoparticles as compared to even the white curcumin, as such. And the combination, when we talk of the combination of tacrolimus and the lipidic nanoparticle of white curcumin, it shows again 98.7% and 111.2% viability even after 24 hours, which was an excellent observation. It really helped us, motivated us that yes, the product which we are working on is really working well because it's free from any toxicity. So here you can see the uptake, the cellular uptake study, wherein we could see that there was a concentration dependent uptake with the increase in the LNs. So as we were increasing the concentration, we could very clearly see that there is increase in the concentration of, increase in the cellular uptake of the lipidic nanoparticle into the HDF cells. So here, these colors they are indicating. So we can see with this color, that is the dark orange color, we can very clearly see that more is the concentration of these, more is the cellular intake. This indicates the fluorescence intensity clearly indicates the enhanced uptake into the cells once the lipidic nanoparticles they were treated or incubated with these particular category of cells. Coming to the pharmacodynamic activity, the pharmacodynamic activity was tested in a hemichioid induced psoriasis model wherein we induced the psoriasis in animals post application of imiquoid for the period of 6 days. And then we start, we have all these groups which were being tested, the naive control, which was kept per se, the positive control, the blank lipidic nanoparticles loaded into the ointment, the free drug, the marketed drug, which was the Tacrolimus ointment available in the market, and then the THC Tacrolimus ointment, which is our final product. And the results were very amazing and very promising. We could see that, from starting from the second day, so naive group is definitely going to be the same, but when we tested it, because we had to develop that model, we could see on the 6th day the positive control, the MEQoid induced model, we can very clearly see that we could see those striations which are marked of the induction of psoriasis and inflammation on the skin, the redness on the skin, the itcher formation on the skin is very clearly visible here. And post treatment with the free drug, the marketed tacros, and the ointment, you can see the difference in the treatment, post treatment with the ointment loaded with both the free drug, that is white curcumin, though they were able to produce certain effects. We cannot negate the fact that they are working well, but the kind of effects which we could observe with the present product, that is white curcumin and tacrolimus ointment, they were amazing. There, this white curcumin is having a beautiful property that it is a depigmenting agent, so it's not going to leave even a scar post treatment. And there were no change in the body weight or even the ear thickness post treatment. When we talk about the PASI score, that is the psoriasis area and severity index, we could observe in this scaling, our formulation didn't produce any of the reaction on the skin. So the PASI score for the present formulation, we can see here the THC Tacro ointment, which it was the least score which we could get here in all the days. So it was least with our treatment as compared to the positive control or the other group, the free drug or the blank SLNs or the Tacros, the marketed formulation even. Now, coming to one of the important effects here, that Tacrolimus forte, it has a effect to decrease down the size of the spleen, whereas when we applied our product, we could see that there was no change in the size of the spleen observed. So there was no splenomegaly in case we were applying our product as compared to that of the free drug or the marketed product, that is Tacros forte. And similar observations were observed in case of the spleen weight even. So the histopathological studies, they clearly, they were an evidence of whatever we did. They confirmed the efficacy of the developed ointment for the treatment of amicoid-induced psoriasis, and THC repressed the side effect caused by tacrolimus. This molecule, tacrolimus, has a very burning sensation when you apply it per se. So, because THC was loaded into lipidic nanoparticle and in the formulation, the patented formulation, we have added a few vectors to reduce down the burning sensation and the irritation which is caused by tacrolimus. So, because of the beautiful antioxidant properties and the anti-inflammatory properties of white curcumin, it could reduce down the burning sensation and irritation which was being caused by tacrolimus. So this is a proof of the synergism which we had developed here with lipidic nanoparticle of curcumin added into the tacrolimus ointment. So the conclusion is all the studies which we conducted, they were very clearly indicative of the enhanced therapeutic efficacy of the developed novel product and the patented product for skin inflammatory conditions. And definitely we are working for the clinical trials which are warranted in this area so that we can make it a commercially viable product. These are a few of the commercialization efforts. So the first part of the technology, that is the lipidic nanoparticles, has been transferred to the company, that is High Tech Formulation. It's been given to him and it's in process to market it, to develop it as a scaled up product for cosmetic use. These are a few of the publications which are related to the work which has been shown here today. This is my research team and we worked together to develop this product. So thank you so much, all of you. At the onset, I wish to thank the organizers for giving me this opportunity to interact with you all.